Hello everyone, welcome to the course Geotechnical Engineering 2. So, in this particular lecture number 5, we will be discussing on the Moore-Coulomb theories. Okay. Previously, we have discussed to the basic mechanism to the strength, that is shear strength, where we have discussed the stress system for a principal plane and then for a planes which are not as principal planes, and then we have solved some of the problems using these concepts. Now, we will be looking at some of the Moore-Coulomb theories, or it is also known as Moore-Coulomb failure theories. Okay. That means, we will be understanding this for a particular soil, the failure criteria. Okay. Let us look at this in the course now. So, I have just mentioned here what we have discussed till now. So, in the previous session 2, we have considered a plane with sigma 3 and sigma 1 as the principal stresses, and we have obtained the shear stress as well as the normal stress on this particular failure plane AB, which is making an angle theta. Okay. Similarly, in session number 3, we have discussed a similar kind of body which is having sigma x on the horizontal direction and sigma y as the vertical direction, and then tau xy along the surface. So, for this also we have obtained tau xy, and then for this also we have obtained sigma x and sigma y and tau xy. Using these three, we have obtained the tau and sigma for this particular failure plane on this surface because of these external loads. Okay. And we have obtained these two expressions. I hope this is clear till now. So, now let us look at the Moore-Coulomb theory. Okay. So, imagine this is a particular soil mass. Imagine this is a particular soil mass and this is another particular soil mass. Okay. And on this particular soil mass there is a strip footing. We know what is a footing. So, that means there is some external load as a strip footing which is a concrete one. In this particular case, let us say this is an embankment. So, on this particular level of soil there is another additional soil. So, that means this entire thing, whatever load that is coming on to this soil at this level will be the self weight of this soil. Now, so that is why I have represented this as the strip footing and this as the embankment. So, because of these loads, if I have to say because of this concrete load, because it will, this soil will try to move down. Okay, because of this external load. Similarly, at this particular point, because of this additional load above, this soil will try to move. So, that means along a certain time after a certain time, there will be a failure. So, let us assume for time being the failure plane is occurring in this manner. Okay. The failure plane is occurring in this manner. That means, if you look at this particular diagram, because of this additional concrete block, when this is moving downwards, this soil is trying to move downwards and move in this manner. That means, there is a failure, okay, failure along this particular plane. So, if you look at this diagram, arrow marks here represented in the opposite direction, that means the soil below is trying to resist it. If you say this particular soil is moving like this, or this particular plane is moving like this, the bottom plate will try to resist it. So, in a similar fashion, this bottom soil is trying to resist the soil from not failing. So, if it fails anyway, this crack will be observed, but this is trying to resist. So, that is why it is in the opposite direction. Okay. So, the soil is moving in this manner, but the resistance is offered in this opposite direction. So, similarly, if you look at this, in this case it is completely due to the self weight of the soil alone. Here there is an external load, but in this case there is a same soil which is trying to move down. Okay. Let us say it is not stable and it is trying to move down. So, let us assume the failure is taking along this plane. So, the resistance offered by the bottom plate is in the opposite direction. Okay. So, that is why this term, the resistance offered by this bottom soils along the failure plane is nothing but by mobilized shear resistance. Okay. It is known as the mobilized shear resistance. So, in general, as I have stated, the shear failure whatever is occurring due to the shear forces only. Okay. Now, so these are the failure surfaces. So, if you look at, as Moore stated, that if you look at this failure plane, what are the major stresses that are causing this failure? These are entirely due to normal stress and shear stress along the plane. Okay. So, till now we have considered normal two dimensional body. Okay. in the previous sessions, but here coming to the real life application, we need to find out where this failure is happening, okay, where this failure is happening, and these failure because of what factors the failure is happening. That means because of sigma and tau the failure is occurring. So that is what as Moore has stated. So it is occurring, or the failure is caused due to the critical combination. That means it is not just because of one force alone, it is the combination of sigma as well as tau. Okay, that is what Moore has stated. It is the combination of sigma as well as tau, this failure is happening along the particular plane. Now another thing, this particular sigma and tau, it completely depends upon the failure plane only. Okay. Now apart from this, so as I have stated in the previous sessions, if you look at the shear stress, okay, as we are representing to draw a Moore circle, it is represented on a tau sigma plane only. Okay. That means on the x axis we are considering sigma, on the y axis we are considering tau. So that means simplifying, I can write down any failure for a particular soil, it may happen in such a way that it can be represented by tau f is equals to f of sigma. That means shear stress is a function of sigma. So what happened is, if I have to define regarding the resistance or the strength offered by the soil, that means let us, I am denoting S is the strength, shear strength that is offered by the soil. So I can simply write it is also similar to stress, okay, because of certain stress the resistance which is offered is nothing but stress. So there should be some strength of the soil. So I am representing say the tau f, the tau f as the shear strength S, okay, shear strength is represented as S, which is equals to f of sigma. So what we need to do now, we need to understand this. Since shear strength is a function of sigma, here what happened is, whenever we are representing on a particular plane, this particular equation will actually be some curve, okay, because it is a series of failure regions. Okay. So this will intersect at this particular circle for a particular plane. Okay. For a particular soil, there will be different number of failure surfaces. Okay. Let us say I have drawn a Moore circle only for a particular plane, okay, only for a particular plane which is inclined at an angle theta. Okay. So that will intersect this curve only at one point. Clear? If I consider some other plane now, then say the circle is somewhat like this. Okay. So that means it is not a failure plane, that means it is not failing. If it is not failing, why will it intersect the curve? Okay. So that means this curve or the failure envelope, it is known as a failure envelope. This failure envelope indicates that this is a series of failure points in a particular soil. That means different failure planes may intersect at this particular point. So that is why this is generally obtained from this particular expression f of sigma. Okay. So that is why it is a curved line known as a failure envelope, Okay. Now while considering this failure envelope, if you look at this one, Moore has given this failure envelope will be a curved line, but Coulomb has stated that this curved failure envelope is not a curved line. He stated that it will be a straight line. Okay. He assumed that it is a straight line, and the equation he has given as S is equals to f of sigma will be c plus sigma tan phi. That means this f of sigma is whatever the function, he has stated that it will be c plus sigma tan phi. Clear? So what he meant by that, if you see, this is the curved envelope given by Moore. Okay. That means this is a curved envelope, failure envelope. That means this is a curve which is obtained due to different failure planes, okay, different failure planes considered. Okay. So now this is a failure curved envelope obtained, this is given by Moore. So what Coulomb has stated? Coulomb has stated that this is not a curved line, this will be a straight line, and he has given some expression. So let us say this is a straight line given by Coulomb. Okay. This is a straight line given by Coulomb. That means this is having a particular intercept, right? Okay. Let us say this is the intercept C. and let us say this is making an angle phi, this failure envelope is making an angle phi. Okay. So, he stated that it is an entity, shear strength is an entity in terms of the C and phi apart from your normal stress whatever is acting on that particular failure planes. So, he has given this generalized equation for the entire soil as S is equals to C plus sigma tan phi. I hope this is clear till now. So, as I have stated, where C is the intercept, so this is known as cohesion. Okay. Whatever C that is there in this equation 1.6, C is known as cohesion or cohesion intercept. Okay. Apart from that, there is one more thing, that is phi. Phi is known as the angle of internal resistance or angle of internal friction. Okay. Phi is the angle of this failure envelope along with the horizontal. See, clearly remember, failure envelope is different, failure plane is different. For a particular soil, there will be different failure planes. Okay. If I consider a particular soil, there will be one failure plane at an angle of 12 degrees. Say there will be another failure plane at an angle of say 30 degrees. Say there will be another plane at an angle of 45 degrees. So, for these particular planes, if you draw a particular curve on this tau sigma space, then it will be a curved form known as the failure envelope. So, that failure envelope will make an angle phi. Okay. But Coulomb assumed that this will be a straight line. Okay. So, that is why it is known as a angle of internal friction or angle of internal resistance. Okay. So, this is the main concept behind this particular Mohr-Coulomb theory. Now, so here there is one more small concept. Let us say I have considered only a particular failure plane making an angle theta. So, let us say there is a small, I am just taking a failure plane making an angle theta. So, if initially let us assume I got a circle along this dotted line, okay, along this dotted line, my drawing might not be clear, but imagine this is intersecting along the Mohr circle is intersecting this particular straight line. So, if this is intersecting at this particular point, that means there is a failure. Okay, that means for a particular soil there is one failure plane. Okay. Now, if say imagine this curve is only like this, okay, that means it is not at all intersecting the failure plane. So, for whatever plane I have considered, it is not intersecting the failure plane, that means a failure envelope, that means it is not having any failure along that particular plane. Let us say I am considering another plane which is inclined at an angle say 50 degrees or 60 degrees. So, then this particular circle is somewhat in this manner. Okay, that means this particular above circle is now intersecting this particular straight line at 2 points. That means there is a failure. That failure may occur along this plane. Okay. So, that is why this is unstable plane, and this previously initial one, the smaller one is a stable plane, and this is a plane which is having just a single failure plane. Clear? So, that is how we differentiate between these. Okay. So, let us understand the other concept, revised Mohr-Coulomb equation. Till now we have understood the Mohr-Coulomb equation. So, what do we mean by the revised Mohr-Coulomb equation? So, in later researches it has been clearly observed. If you look at the equation, we know that S is equals to C plus sigma tan phi. Okay. So, that means shear strength is in terms of C, sigma and tan phi. Okay, that means phi. Here it has been stated that C and phi are not the fundamental parameters of determining strength. These are not the fundamental parameters as given in the equation. These are not the fundamental, because of the later research it has been observed that C and phi are not the fundamental properties. So, what are the fundamental properties? Because if you look at the soil, in general soil is homogeneous, but when we consider these are having some moisture parameters, okay, it varies, since cohesion or phi are not the standard one. Okay. It depends upon water content, the drainage conditions and the additional conditions of testing what we are doing. So, these three parameters will influence on the determination of shear strength. Okay. So, that is why we do not consider C and phi. So, what Terzaghi has done, he has revised that whatever normal stress we are considering sigma, but he stated that Terzaghi stated that the normal stress is not the actual control of the shear stress, it is the effective stress. Okay, it is the effective stress considering the influence of pore water pressure. Okay, so that is why effective stress are dominant. So he has revised the equation as S is equals to C dash plus sigma dash tan phi dash. Similar equation what we have learnt, but here it is the effective stresses that are the influencing factors. So that is why S is equals to C dash plus sigma dash tan phi dash. So this is what we have to consider. So this is the revised Mohr-Coulomb equation. This is the revised Mohr-Coulomb equation, and this is the one of the very important engineering property for the determination of shear strength. Okay, so this is the important equation for the determination of shear strength. Clear? Now let us look at the limitations of the Mohr-Coulomb theory. We have understood what is the Mohr-Coulomb theory, what is the revised expression, but there are certain limitations for this also. Okay, let us try to understand what are the limitations here. So if you look at here, this theory also neglects the intermediate principal stresses. We have discussed in our initial class that there is sigma 1, sigma 2 and sigma 3, where sigma 1 is the major principal stress, sigma 3 is the minor principal stress, and sigma 2 is the intermediate stress in between sigma 1 and sigma 3. But this theory also is neglecting sigma 2. Okay, so that is one of the limitation. Okay, apart from that, here if you look, Mohr assumed that it is a curved path, but Coulomb and Terzaghi, they have stated that it is a simple straight line. Okay, so if it is in general it cannot be straight line obviously. So if it is a straight line, it will have some certain angle. Okay, but if it is a curved path, then the angle will be somewhat different, slightly different. So that is why there will be small erroneous result. Okay, so this does not give the exact result. Okay, now so as I have stated that the angle of the failure plane is incorrect. That means if it is a straight line, it is having an angle phi. If it is a curved one, then it will be having some other different angle apart from this. Okay, so there is a slight difference considering this. Now finally, in case of some clay soils, if you look at some of the clay soils, what is the general thing? It can be clearly observed that there is a no fixed relationship between these normal and shear stresses. Okay, why? Because if you consider some particular soil, in case of some type of clay soils, the failure plane will exactly not be a straight line, it will be somewhat irregular. So what happens when it is irregular? That means there will be different values of tau, different values of sigma. If there are different values of tau and different values of sigma, how can this theory be appropriate? That is why this theory cannot be applied for such type of soils. Okay, only in soils where there is a homogeneous failure with a single plane or a straight line plane, then only this theory can be applicable. That is why in some of the clay soils this cannot be applicable. Clear? So these are some of the limitations. So I have mentioned some of the assignment questions just for your understanding here. Okay, just for your self assessment, try to write down on your own. Okay, so in the upcoming lecture we will be discussing on the different tests, okay, to determine the shear strength of a soil in the laboratory, along with some of the different drainage conditions and some of the stress strain relationships for this. Okay, we will be understanding the tests along with different drainage conditions. There are different drainage conditions, and then we will be understanding the stress strain relationship for this particular cases. Okay, so this is what we will be understanding. So thank you very much for this particular lecture.